Hello everyone, thanks for joining this session. Today we learn what machine learning is, what are its types, and what can we do with this machine learning, and a few algorithms using the Python packages. So let me share the screen with you now. Okay. So first we have introduction on machine learning, then we'll be seeing the types of machine learning, and we see what we can do with this machine learning and some Python packages like NumPy, Panda, and Matplotlib with a few algorithms. Okay. So to start with, we'll see what artificial intelligence is. So we all know artificial intelligence refers to the simulation of a human intelligence in a machine that are programmed to think or act like human. Right? And AI can be applied to many different sectors and industries. And goals of this AI include learning, reasoning, and perception. And the algorithms which we are going to write in Python program or in R program in whatever language we want, that algorithms plays a very important part in the structure of AI. Okay, and this machine learning is a subset of AI that includes statistical techniques. So here we'll be writing an algorithm which deals with the statistical techniques that enables a machine to improve certain tasks. And the next subset is deep learning. Deep learning is a subset of machine learning. Here also we'll be making a model or we'll be writing an algorithm. But these algorithms are the complex algorithms to achieve the certain task. Okay. So actually this is a subset of ML composed of algorithm to perform the task by exposing the multi-layered neural networks. So deep learning deals with the multi-layered neural networks like a speech or image recognitions. So this requires a technique to achieve the complex AI. So the next we see in detail about the machine learning. So we'll see what machine learning is. Okay, so here you are seeing the objects, and if I ask you to identify the object, we can easily identify with the similarities, but the machine cannot do it on its own. So we look with the similarities and identify the objects, but a machine cannot look for the similarities on its own. So the first thing what we need to do is we have to make the machine to learn all the features associated with the objects. That we call it as training. So we are making the machine to think on its own, and we give a machine the ability to learn without being explicitly programmed. That is machine learning. So here we are giving the features associated with all the objects as an input data, and we are creating an algorithm which analyzes all the input data given by us, and it learns on its own. Okay, we will be writing the algorithm in such a way that when new data comes, we call that as a data, it can identify with the help of the already learned data. Okay, so and then it gives us the input. So basically it gives a machine that we are giving the machine the ability to learn without being explicitly programmed. That we call it as machine learning. Okay, so we have three types of machine learning. One is supervised learning, unsupervised learning, and reinforcement learning. We'll see these types one by one. Okay. This supervised learning is a process of making an algorithm to learn or to map an input to a particular output. So this is achieved using the label data set. So data sets are the collection of data we have in our file. So using those data sets, that will be a label data sets. If it can achieve only through the label data set, and with the known data and with the known response, we are creating an algorithm, and that identifies a new data whether it belongs to this category or not. Okay, so here we have an example of the known data apple, and we have the responses about these apples. So we will be writing an algorithm which identifies with the help of the known data and known response. If some new data enters into the model, it identifies with these two data and then it gives an output as apple. So this is supervised learning, and basically it tells how does the independent variable differs with respect to the dependent variable. We'll be seeing the types of supervised learning here. So when I say we have a known data and the known response, if the output variable is a continuous numerical variable, we can say that as a regression model. And if the output variable is a categorical variable, we say that is a classification. So regression and classification are the two uh, types of supervised learning we have. So in this example, if you see the housing price, and here we have the size of the land. So based on the size, the housing prices differs. So here we see how does the housing price varies with respect to the size of the square feet, the size of the land. So all the inputs we have here is a numerical data. So we can consider this as a regression model. Okay. So the output variable is a continuous numerical value. So we call this as a regression model. We have another type of label data where we need to make a decision on whether we can play in this weather or not. So in that case, we don't have any numerical data. We may come across the decision making thing. So we call this as a categorical thing. So we classify the data. We are trying to determine the output based on the categories as or no. Okay, so this type of data we call it as a we have an algorithm in classification. We call it as a classification supervised learning, and we have certain algorithm to deal with these type of data. So when we are getting a data set, first thing we need to see whether it's a numerical, whether our output variable is a continuous numerical variable or the output variable is categorical variable. So based on that, we'll be implementing the algorithms for regression or the classification. So we have many regression algorithms like linear regression, logistic regression. We have many algorithms to deal with these kind of data, and we have many algorithms, classification algorithms to deal with these kind of data. So the moment we get the data, we have to classify these two and which category our output variable belongs to. Okay. So the right. So the best example for the supervised learning is the spam classifier. Right, here we have certain mails which are with our knowledge we are treating that as a spam, and these are all the not spam. So how does the spam classifier work? It has some phrases like you won the lottery, and you won 1,000 rupees cash. All these kinds of words have been packed as a one bunch. Okay, and that will be considered as a spam words. So it will be keep on collecting those words, and whenever it recognizes that type of words, it consider that mail as a spam, and then it the rest of the mail will be the not spam mail. So it will be categorized with the um, input data. So and this can be achieved, and it is being constantly updated by the new technologies or the feedback by the Gmail users. So with the help of these constant update, the words have been packed in such a way that these are the words belong to the spam mail, and these are the words can be the no, can belongs to the non spam mail. Okay, so it requires a lot of algorithms, it requires a lot of learning with the help of the input data. Okay, but nowadays in modern spam filter, you can even identify the phrases even if you have the misspelled words by the character substitution program. So even the spam, if you're saying in case of you one, if you are missing some letter, in that case also it can be identified with the help of character substitution. So in modern spam filter, they have improvised the algorithm in such a way that it can identify the misspelled spam words also. So it will be grouped, all the spam words will be all these phrases will be packed separately, and then with the help of the algorithm we are training, it identifies the mail whether it's a spam or not. So it works by using the algorithm on which words or phrases mostly used in the spam mail. Okay, so this is the best example for supervised learning. All the words we have the labels, and with the help of these labels, we'll be writing an algorithm. And definitely, it requires a complex algorithm steps. It is not easy to do it in one simple program. So we have to learn the pattern of all these words and then categorize whether it's a spam or not. So it comes under the supervised learning. Okay, the next part is the unsupervised learning. Okay, so this model gets a train to find existing pattern in the data to more about the hidden information. So in unsupervised learning, we don't have the labeled class. See, if you see here, all the pictures we have a data, but we don't have any specific label or class to categorize this. So we have to create a model in such a way that we have to train these kind of data to find the existing pattern in the data, to know more about the hidden information. So we have to learn this data, find the hidden information or patterns, and then we give this input data uh, with the classes. So we are going to categorize with the help of the hidden informations into it. Okay, so this can be done with the help of clustering or associations. The clustering discovers the inherent categories with the data to a group. So it groups the data with the inherent categories. And association is discovering the rules that describe data and association between them for the recommendations. Okay, so these are the two types of unsupervised learning. With the help of this clustering and association, we can categorize these labels and we put it here. And here, if you see, when you are coming with the analysis, we have all these green, red, and blue dots together. So all these are the input data without any labels, and with the help of unsupervised learning algorithms, we can categorize, we can cluster them separately, all the greens on one side, blue in one side, and red in one side. So we can do this clustering of data with the help of unsupervised learning algorithms. So here, the same example, with no labels, we have animals and birds. If we are creating a model in such a way that it can identify some pattern into the input data and it can classify into three clusters, it can do with the birds and reptiles and then the animals. Okay, so here in unsupervised learning, we have a clustering and an association algorithms where it can uh, do this type of categorization. So we will be using the algorithms of unsupervised learning if we are having the data set with no labels. Okay, so the best example is the Netflix recommendation. So the 80% of the TV shows are on the Netflix are discovered with a pattern what do we say, the pattern recognitions, right? So they will be watching you what kind of genre or what kind of content you are watching every day, and it gets a input from lot of users, millions of users, and then based on those input, it can generate an algorithm and it gives you the recommendation platform in the in your window. Okay, so it uses a machine learning algorithm to recommend you the list of movies or the fine shows that you might have already seen or already watched that. Okay, so it looks through the thread of content rather than the genre, and then it also looks through the hidden factors, hidden informations from other users also. And it creates and it keeps track of each and every profile, and then it combines all the data and develop a machine learning model to analyze a pattern or taste, and then it displays in your screen. So here it is a best example for supervised learning where all the genre or content, we don't have any label for that, and whatever the user is viewing, there is no pattern into it, there is no proper class or label into it. All the inputs, 250 million people, the profile input will be gathered in one data set, and with the help of the algorithm, the unsupervised learning algorithm, it can identify some pattern and categorizing it, and it gives you the recommendation on your page. Of course, it requires a multiple algorithm procedures and it requires a complex program to write it. It is not done in one simple program. Okay, so and this is the best example for unsupervised learning. The next we come across the reinforcement learning. The first we have seen supervised learning where we have a label data set, and the second one is the unsupervised learning where we have the data set with no class or labels. And then now we are going to talk about reinforcement learning. Okay, in reinforcement learning, we see the goal. Okay, so the system has to perform certain task. First, it performs the task, it observes the environment, and then it takes all the corrective measures, it comes to the system again, it corrects the errors, and then it implements again. So this process is a continuous process. So the best example is the self-driving cars So here it uses the IoT sensors to record all the blind spots, and it has a forward camera and it has ultrasonic navigations. So with the help of these IoT sensors, it senses all the environment, and then it has IoT connectivity, which includes a cloud computing, and then it connects with the mapping and for directing the cars. And then we have the software algorithm where it collects all the data. And here in the software algorithm, the reinforcement learning happens, and we are writing an algorithm to observe all the informations gathered with the help of IoT sensors and IoT connectivity, and we'll be learning those observations. We come into the model in such a way that the car can have the self-driving mode. And again, if we are hitting with some other objects, and if we are identifying some other obstacles, again that can be a learning. Again, it goes to the observation, we create a model, we correct the model, and then the action is being done. So it is a continuous process. So with the help of the multiple the multiple what do we say the atoms, we can come into the some kind of conclusion to do such a kind of automation, right? So this is the best example for reinforcement learning. The self-driving car, they are still trying to have the self-driving car, but still in certain areas they can observe the environment, where the trees are, where are the buildings, with the help of the colors. Here if you see, they are identifying the sky with this ash color, they are identifying green with the trees, and they are identifying the red color with the building. So these are the things they are training the algorithm by taking these kind of inputs, and they are trying their level best to make this car work on its own. So this kind of learning is a reinforcement learning. Okay, so the next. Right. So we have seen what supervised learning is, and what is unsupervised learning, and what reinforcement learning is. The supervised learning, we give the data with the sorry labels, and then we will be getting the output based on the known data. And then in unsupervised learning, the data set we give is without labels, and based on the informations gathered and pattern match, it gives you the output. And in reinforcement learning, we'll give the output based on the learning it has happened with the error occurred, and we can get the desired output. So these are the types of machine learning. Okay. So in machine learning, I told we have different type of algorithms. So today I'll take a linear regression model algorithm for you to explain how the Python program is used in this machine learning. So the linear regression model is um, it is actually plotting a straight line to form a y is equal to mx plus c. Okay, in such that it can predict the new data. Okay, if your model is well trained using the linear regression model, then in that case the predicted point will be in the regression line. Okay, our aim is to draw this line, this line of regression, and we'll see where our predicted model is. So aim is to draw a line of regression, and here the x is the independent variable and y is a dependent variable. The data point in x axis, if the data point in x axis increases, if the y value is also increases, then the regression line is positive. If the data point value decreases and y value increases, then the we call that as a negative line. Okay, so here in every single point we'll be taking the least square method. With the help of least square method, we'll be um, taking the closer regression line. Closer the regression line lies near the actual value. Okay, so this is an example for linear regression, and this is a non-linear regression. Okay, fine. So here if you see, we have an independent variable x, and then here we have a dependent variable y. When the independent variable increases, the value of y is also increased. So we are getting a line like this, which is a positive line. And here in this case, the independent variable increases and the dependent variable decreases. Here we get this kind of line where we call it as a negative regression line. Okay. So in the line will be passes through the mean of x and y. Okay, so we have x, we have y. right? And we need the intersection of both the lines, and that is where the line of regression is drawn. So this is the intersection points where we are drawing the line of regression. And we have to find the mean of x and mean of y, and we'll be applying some mathematical concept. Y is equal to mx plus c, and we need to find the value of m, which is slope, and we need to find the value of c. C is a y intercept. So with the mathematical calculations, we need to arrive the point of m and then c, and then we'll see the value of y if the value of x differs. I'm not going deep into the mathematical concept today. Okay, so I'm going to take you to the program where we can analyze this thing. If one variable is increasing, or if one variable changes, how the impact of that variable is being done in the another variable. So we are going to see that example in the Python program. And here the thing is, I am showing this diagram because here we are writing the drawing the line, and the actual point lies in the drawing, okay, in this line. So here we have estimated value, this is the actual value. The error, the difference between the estimated value and the actual value is the error. Okay, so our aim is to reduce this error. So we are going to draw a line, this is one line, and we are going to draw multiple lines where we can reduce this error value. Okay, so for to achieve this, we have one parameter called r square. It is a parameter which tells us the independent variable is related to the dependent variable or not. Okay, so if we are bringing some new data into it, and it tells us whether that independent variable is related to the dependent variable or not. If yes, how much it is, and if it is no, how much it is. Okay, so the r square value starts from 0 to 100%. More the value of r is our predicted if the r square value is equal to 1, the predicted and the actual value is almost overlaps with each other. It means our predicted value is more accurate. So if it is closer to 1, then our predicted value is more accurate. So our aim is to find out the predicted value so that it fits into this particular model. Okay, so this is a mathematical calculation behind this linear regression. I'm not going deep into this. The basic thing is we are drawing a regression line using the intercept point here, and these are the steps to find out the slope and find out the intersection point and then the intercept. Okay, so with the help of these calculation, they found the intercept point c is equal to 3.3 and the mean is 0.1. And then with the help of all the input, they are considering the value of x is 1 2 3 4 5. If the value of x is 1 2 3 4 5, what will be the predicted value of y? This is what they are doing here with the example of the mathematical equations. So we will be seeing this concept in detail when we are learning a linear regression in detail. Okay, so these are the mathematics behind this linear regression. This is the line of regression we got after all these calculations, and these are all our input variable, and this is a regression line. If you see the actual point and the estimated point, this is the error between these two. The difference between the actual point and estimated point is the error, and our aim is to minimize this error, and we have to find the predicted value. Okay, so here in this case, the predicted value is 0.36, which is 36 percentage we have. And if the r square value is almost equal to 1, then our predicted value is a good one. So our model is, we consider our model as a good model if our predicted error is less. Okay, so I'll show you the program. Let me share the screen with you. Okay, so this is my Jupyter window where I'm writing the Python program to run this linear regression algorithm. Okay, here I'm using the packages called NumPy, the Matplotlib, and the Pandas. The NumPy is a library of Python used for the large data, and it is a numeric computing Python package. And if we have a data in an array which has many features, then we can use this NumPy. And the it is a core library for scientific computing in Python, and it provides high performance multidimensional array objects and tools for working with these arrays. Okay, so it deals with n dimensional array. So if I take one data set which has the many features and many columns or attributes, then we can download that data set with the help of this numpy. And then the pandas also the high performance manipulation, and it is used to analyze the tool using the powerful data structures. So in pandas we have the data structures deals with a one dimensional array, and we have the data frame which deals with the two dimensional data structure, and we have a panel which deals with the three dimensional graphical representation. So we'll be importing these packages from we'll be importing these packages from the Python library, and we'll use it in our algorithm. Okay, and matplotlib is used to represent our data in a graphical form. So I also include that library. So first we need to import these, install these packages in your system, and then we will be using this package. If we are importing this numpy, matplotlib, and then the panda, then we are importing the data set. So the steps for writing the algorithm, the first step is to explore the data. The data exploration is very important because we have to see the pattern and the behavior of the character. Suppose I am bringing one data set, and that data set has got many number of fields and features. So I have to decide which field I'm going to take into consideration for my analysis. Okay, so that data exploration part plays an important role in this machine learning. So I am exploring the data. I have one data set called auto insurance payment.csv. So I'm bringing that excel file here, the csv file here, with the help of command data set is equal to, I'm storing that in one data set, and the command is pd dot read csv. I'm reading the csv file, so I'm writing read csv. If it is an excel, you can write excel. So I'm reading the entire data now. Okay, so I have many columns and many rows into it. So I want to see first five or four columns, so four rows into it. So I'm using this head command which gives you the first five rows. Okay, I'm exploring the data, and I'm seeing the fields of number of claims and total payment. So I'm considering these two fields for my analysis. So first you have to explore the data, see all the fields into it, and with the help of your analyzing skill, you choose a data which you want to do for your analysis. So I'm choosing these two data, number of claims and the total payment, and then I'm taking these two column for my consideration. Okay, so with the help of these two, I'm going to do my analysis. So this is a tail command gives you the last few records, and data set dot shape gives you the total number of rows and columns. I have two columns and 63 rows. Okay, but pandas can deal with a multiple dimensional array. So even if you have many fields, if you have 4 or 10 or 15 columns, you have to choose any two fields or any one field for your comparison. Okay, so here in my linear regression, I am taking one field as a independent variable and another field as a dependent variable, and I'm going to see how the my dependent variable varies with respect to the independent variable. Okay, so I have considering these two variables. Okay, so the next is data shape I have seen. The hist is the histogram. You can see the bar graph. It is good for the analysis. You can easily get to know what type of fields you can choose for analysis. So all these comes under the data exploration. We are just exploring the data in different way to find out the best fields for our analysis. Okay. So the next thing is we are describing, again we are describing the entire thing. The describe command gives you the count, the mean, the standard deviation, and what is the 25%, 70%, or even the maximum value of the fields given in this. So our data exploration part is done. Now after exploring the data, I have decided to use these two columns. Right now I am having these two columns in my table. Suppose if you have multiple columns, we are going to decide which two columns you are going to take into consideration. After exploring the data, I have decided to take these two columns for my analysis. So data exploration is done. So I decided I want this independent variable to be this field. Okay, the minus 1 is nothing but this field, and then the dependent variable is this field. Okay, so now I'm taking this shape of x, so I'm considering one field as for x and I'm considering one field for y. So after exploration, I'm taking I'm assigning x and y with the features or the field names, and here we are going to equate the regression model. Y is equal to mx plus c is a regression equation. With the help of the assigned x and y, I'm going to equate the regression model. Okay. Then we are going to split the data for training and testing. So using the train test model, we have certain packages in Python to do certain things, and testing the model is nothing but performance in terms of accuracy. So we are testing the model performance in terms of accuracy and precision of the model. Okay, so the first we are going to split the data for training and then testing. Training, we can say it's a feature of algorithm like uh, we have some sklearn feature for doing this, and training is actually determining or learning the good values for all the weights predicted in the label. Okay, so if you are learning the good values for all the weights predicted, the labels from the features, it tunes it for the for our need. Okay, so we are training the data with the help of all the inputs we have, and we will be giving the predicted label so that we can use it in our business model. Suppose if the predicted label from the features tuning it for the we can tune it for the business needs, and we can do the validation of the particular data. If the business requirement changes, we can generate a new labeled items. So right now I am choosing only these two labeled items for my training. I am going to predict the exact values. I am going to bring up the model with the known informations about that particular data. So that is training, and then in testing the model, we will be getting the we'll be testing the model performance in terms of the accuracy and the precision of the model. So the model evaluation aims to estimate the generalization accuracy of the model on future data. So that is what our aim is. So we are going to create an algorithm in such a way that it estimate the generalization accuracy of a model on a future data. If some data enters into the model, it has to estimate the accuracy of the particular data. Okay, so determining the accuracy of the model and comparing the predicted value with the actual value by calculating the error using the measures like the mean absolute or something like r square. So we will be giving our analysis to the company. Okay, so for the training data, we have to consider these two values. So we are splitting the data for training, and then we are taking the data for testing using the field called train test split method. And we have sklearn. Sklearn is a machine learning library in Python. It features the algorithms. It supports all the algorithms where it has a feature to test and train the data. Okay, so we are going to use this sklearn, or we can use a slice operator in the Python program, but here we are going to use only the sklearn package. Okay, so we have to import the regression algorithm from the sklearn, and then we'll be testing the model for the performance in terms of accuracy and precision, and then the test the data set to validate the model using the predict method, and then we calculate the error report with the help of mean square error, and then we plot a graph and do the analysis. So this is the general procedure for writing the algorithm. So I am taking these two values, x and y values, in this algorithm. So I'm taking, okay, so with the help of matplotlib, I'm just drawing a graph and seeing how the data set is. I'm just visualizing the data set. For that, we have a command called scatter x and y. We have the x value and y value. Okay, so the total payment is a y value, a number of claims is x value. So if the x value increases, how the y value is increasing. We are seeing that pattern, and I'm giving the title as the Swedish automobile insurance, and x value title is the number of claims, and y value is total payment. Now I'm writing the command called plt show. So if you run this command, for running this command in Jupyter, you have to press shift and enter every time for each and every command. So moment you press the shift and enter, though you can see the output here. So this is a diagrammatical representation of our analysis. Okay, so we got some idea about how these two variables are being related. Then I'm splitting and testing. I'm splitting the data set for testing and training. So with the help of this sklearn model, the sklearn model select, and I'm importing the test train split. This is one method in sklearn. I'm importing this method. With the help of this method, I'm training the x variable, and then I'm going to test the x variable the same way, train the y variable and test the y variable. So I'm storing all these values in this. Okay, so now I'm going to run the linear regression algorithm. So the linear regression algorithm, whatever I have explained as a mathematical concept, is already been done in the Python package. So we are going to import the regression algorithm from the sklearn. Okay, so we have to include this command sklearn.linear model, importing the linear regression. So with the help of the x train and the y train, so we are storing that value in the regressor. Okay, so here we have one model called fit linear method, and fit linear method gives you the exact prediction. Using the linear model, it gives you the exact prediction. Okay, so it gives you the error, the number of errors occurred when we calculate the mean square error. So it fits the model, it gives you the best fit, because we have seen in the diagram, we have seen only one regression line being drawn, but this fit program will run the multiple regression lines, and it gives you the best regression line and the best point for this particular model. So this linear regression model, this package takes care of, this library takes care of that testing and training for different regression lines, and then it gives you the best fit line. Okay, so here regressor dot fit, we are giving the x train value and y train value for this fitness, and it gives you the best fit. So here we have this value and storing it in y predictor. Then we are finding the value of coefficient and intercept. Right. So as I told you, we are plotting the graph to show the result via matplotlib, and then we will be taking the r square value, right? So the r square is the coefficient of it's a parameter which tells us the independent variable is related to the dependent variable or not, and if it is related, how much it is being related to that, right? So the r square value gives us that prediction. So if r square value is equal to 1, then both the values we can rely on that both the values are highly related, and it varies from 0 to 100%. So in this case, if you see the r square value, so here we have the formula to find the mean absolute, mean square errors, and then the root mean square variance. So all these are the input for doing your analysis. Right now I'm seeing only the r square value. So the R square value is 0.64, which is 64%. So it tells us this independent variable is 64% related to that dependent variable. So this is what we got for the R square, and the machine learning is more into the interpretation. We have seen these kind of statistical output with the help of the sklearn package, but with the help of absolute mean absolute error, we have some value, and mean square error we have some value, root mean square we have some value, and variance we have some value. So with the help of a statistical knowledge, we are going to interpret the data set, how far we are doing this analysis. So here I am taking only the r square value, where it gives you the parameter which tells the independent variable is related to dependent variable or not, because I have taken this simple linear regression algorithm for as an example. So I can, with the help of this r square value, I can interpret this the data which we have given, the number of claims and the total payment. So the total payment is 64% related to the number of claims. So the value of total payment differs. With respect to the number of claims, and that accuracy of that difference may be a 64%. So this is how we can interpret the data with respect to the analysis. right? So like this we have a different algorithms where we will be getting the exact statistical method, and the important part relies on how we are interpreting the statistics into it. Okay, so if your model is whether this whatever algorithm you have done, whether your model is the good model or not, all these will happen with the help of a few more procedures to see the fitness of this particular algorithm, and then we interpret the data how accurate your model is. This is such a simple example where I am explaining only about the r square value and how the x and y variables are related. Okay, so the same thing can be analyzed with the help of the diagram, with the help of this matplotlib. You can see the regression line here and all the points. So this is our training set, and we can see our test set like this. Okay, so with the help of this diagram, we can interpret the model what we have done. Okay, so today we have taken only the simple linear regression, and we have taken two fields x and y, and we are testing how far that independent variable is related to the dependent variable. In our data, whatever data we had, we are seeing that r square value is equal is 64%, right? So if it is nearer to 100 percentage, then we can say that a y is completely depend on that x variable. So whatever variable we have taken, there is some relation into these two variables. Okay, so this is one simple example in Python program to write an algorithm. We have different algorithms for each and every set of problems. In supervised learning, if you take regression, we have linear regression and logistic regression, and in classifications we have k-mean and other important classification algorithms to deal with such kind of data. And if it is a reinforcement learning, we have the data with all these automated system. We have the input from the environment, we have to analyze the data, and we give the best model. So the machine learning deals with the writing the algorithm or the model which can improvise a system to do the work on their own. So the more accurate your model, the successful the machine learning is. Okay, so I think you have enjoyed this session, and I hope you got some idea about what machine learning is, and how it is being used in the real world business. I hope you enjoy this session. So thanks for joining, and bye bye.